Yeah. So,
To be honest, that's the part of our job that I haven't been doing, which is minutes.
That's very generous of you.
I mean, I don't expect.
I think they're ready.
You think so? Yeah. Store. Oh, I know.
Okay, who's ready for Dnssd? Yay!
yeah, there is. Make it bigger.
Okay, so you know what the first questions are. Who's going to be the note taker and the Jabber scribe? Come on, don't be shy. Eric.
Which one do you want to do?
But wait, you're the AD. That's just
Not quite.
that's
Okay, not yet.
Come on, you slackers. Come on, the rest of you slackers. I'm sorry, not slackers. People sitting reading their email. Please, won't somebody help with Jabber or note taking? Pretty, please.
I can do Jabber, but we need a note taker.
Well, I can take notes.
Okay. And I'll be on Etherpad too, but I need, Thank you.
Yeah, and Eric, if you want to fill in some stuff on there as well,
yeah.
perfect, thanks.
So we most of us take notes?
So on the Etherpad, it's synced up. So
Where's the
You'll find it. You'll find it on the agenda. There's a link to it. That's my favorite place.
is it still on there? Or even just if you get to the IETF agenda.
Yes,
big
that's
page,
the
not
agenda. I
ER
was
agenda.
right. The IETF agenda.
Yeah, I'm sorry.
It says new tab.
Okay.
You what?
Is that microphone on?
Oh, we're not speaking in the mic. Yeah. All right.
But it does. Oh, wait. So it's directional?
Yeah, these are incredibly directional.
Was that on?
Yeah.
Okay.
All right. Thanks.
Hit it, David.
All right. Welcome to Dnssd. If this is not the working group you're looking for, this is the wrong room. So especially since this is Monday, this is the note well. Please note well the note well. In particular, and seriously, do read it if you haven't, and if you're a new IETF attendee, or if you're a longtime IETF attendee who still hasn't read it. Just talking at the microphone actually is a liability for you in terms of patents and disclosing them. So if you know about patents and you go say something, you have to say something. So before you do, make sure you read the note well and know your responsibilities. We also have a code of conduct, which is discussed there. So please read those things and behave accordingly. All right, thank you. So again, some reminders that should be obvious to people, but even the people who have been here for the longest are the ones who forget the most often. Please state your name clearly anytime you go up to the microphone. And please review documents and send feedback on them, even if the feedback is just looks good, because when you write documents, you also want other people to read them. And the blue sheets. This is a reminder for me to send out the blue sheets.
I forgot to put
All right. So that's the part when the secretary. All right. The blue sheets will be coming to you very soon. All right. We have a minute taker and a Jabber relay. Did the both of you find the link for the Etherpad? Stuart?
Yep.
Cool. Thanks. So we have a Jabber page. I'll be keeping an eye on it. If people say something there, I'll relay it at the microphone. So these are just links for people who are not necessarily in the room or looking at these PDFs later, but they're just the data tracker for what we're doing. As a quick reminder, we have a working group GitHub organization. We encourage document authors to move their documents there if they feel like it, but it is absolutely not a requirement. And we have a new area director. So, all right, we will on Thursday have a new area director. So first off, I'd like to take a second to thank Terry for his years as area director. So could I have a round of applause, please?
It's been an absolute pleasure. This working group has been one of the most collegiate, professional, active working groups I've ever had the pleasure of being engaged with. Thank you.
Thanks, Terry. And thanks to the working group participants for making that way. And let's keep it that way because it's great. And let's have a round of applause in advance for Thursday for Eric, who's going to be here. All right, so our goals for today are, in a nutshell, similar to where we were at 3 months in Bangkok, but we've made progress on all of these items, which is nice. So I'm going to start with the discovery proxy push and stateful ops, which we've been talking about for years, but we're getting very close to done. We're going to talk about also the update proxy, private subdomains, timeout resource records, then keep making progress on privacy, which is still, really big work item for us. And then maybe time permitting, spend a little time about recharting afterwards. So kind of similar to what I just said, here's our official agenda. Would anyone like to bash the agenda? Is there anything that you would like to add there or things that you think we should not be discussing? All right, thank you. And we're going to start off with Stuart. Yeah, hold on. All right, try again.
Nope.
What button are you using?
Left and right.
No, I did, but you need to go in the other order as well. Okay, try now. Yes.
All right, thank you, David. We have 3 documents we've been working on for a while that have been slowly going through the process. Good news. DNS stateful operations published last Friday RFC. So that's good. I'm really happy with that document. I think it is, my name is on it, so I don't want to be too self-serving, but I'm really happy with it, and I think it's going to be a good foundation for future extensions. The first of which is push notifications. We've been through working group last call with this. We got some good feedback, and Ted Lemon has been implementing this, and in a way, it's lucky that while we were putting DNS stateful operations through the publication process, we were sitting on this and holding it, because Ted discovered a small flaw. We had previously, before DSO existed, made the decision to adopt the DNS update record format, because where we can reuse existing technology instead of inventing something new, that makes sense. Since that happened, DSO came along and defined the TLV syntax that goes after a conventional DNS message and makes the argument that this is a cleaner way of expressing data rather than trying to overload existing fields and give them new meanings and trying to massage things to look like a resource record, which I think is good advice. We were still using the old DNS update format, which does exactly that. It tries to overload resource record formats. And what Ted noticed is that in a DNS update, the first record in the question section, which is called the zone section in an update, tells you the DNS class of the zone. We don't have that section in a push notification. And when Ted was actually trying to implement this, he said that there's all this weird overloading of what type and class mean in the records to mean add a record or delete a record or delete an entire RR set. And what we were left with was that the DNS class was unspecified. Now, DNS classes are not really used, so maybe that's not important and we can just forget it, but I kind of feel like it's not our place to be making that decision. If DNSOC decides that classes are deprecated, I'm fine with that, but this is not the document to make that decision. So with that, and the realization that we don't have to be constrained to look like resource records, we came up with a simple change. Semantically, it's no different, but it's just a different syntax. And I will send a summary to the mailing list, but while I'm here in the room, we would like people to have a look at that and see if they agree that this is a trivial change and everybody's happy with it. And along the same lines, Ted noticed that the reconfirm operation has a reply, but there was nothing a client could ever do with the reply that was useful. It was just extra bytes being sent, it was extra code being written, waiting for a reply just so you could ignore it. So while we're making this change, it seemed like a useful simplification to just get rid of the replies. So make reconfirm a unidirectional message instead of a request response. So I think those are two worthwhile improvements, and we have updated the document with that new text. I think probably it's worth spending the 2 weeks to do a work group last call, and I fully expect that we'll have no comments in that 2 weeks, but we should give the working group a chance to respond. And after that, we're clear to go to IETF last call, ISG review, and let's make it a goal to have this one with an RFC number by the next IETF meeting in Montreal. Then the other document, discovery proxy.
Actually, Stuart,
Yep.
Before we move on to that, so to give people a little bit of context, the DNS push document had gone through last call before, which had passed, and I think Stuart's approach is really good, doing it again. Well, first off, does anyone in the room, if you have any objections, please come up to the microphone now. Otherwise, we understand that maybe not everyone has read the latest document, and maybe having Stuart's summary on the list will be helpful. So we'll probably start the last call now or whenever I get to the data tracker, and it'll go for 2 weeks starting after the end of this meeting because everyone's busy during this week. But all things considered, I think it'll then move very smoothly because we have had a lot of review of this, and especially now that we have an implementation, which Ted will look into, we're in really good shape. So thanks for everyone who put a lot of work into this.
Yeah, we had some debate about this, and part of me just said, let's just leave it and not worry about it, add a sentence that describes the problem. But after we discussed it a bit more, it felt like we want to make a good protocol. We don't want to compromise. And at this point, a little bit of extra work now to produce something better in the long run, I think, is the right trade-off.
Terry Manderson, currently still AD. I think I concur with the last call. The semantic changes you made are substantive, and I would have pushed back anyway had I have still been in the chair when it got to me. I would still be advising Eric in such a situation to push back on those sort of changes, and hopefully he would also do the same thing for consistency. So yes, great idea. Thank you.
Just to clarify, when you say push back, you say we should still have a last call. Don't
just try and throw it up to the IESG review. Yeah. Absolutely, do your own work. Make sure it's as clean as possible, and there's consensus in the working group on everything.
Thank you.
So on the second document, discovery proxy, this has been through workgroup and IETF last call, and this is right now in the state of waiting for push notifications to be done, which was waiting for DNS stateful operations. Ted and I have also been working on implementing this, and we in the course of discussions of explaining this, it became clear that there were some things in the document that could be explained better. So I have made an attempt to improve the document to explain those things better, and I have a summary here. None of this is changing the behavior or changing the messages that are sent. It is things that we realized were kind of implicit but not stated explicitly. One of those things is the unicast subdomain and the .local collection of information on the local link are more or less a bidirectional mapping. One is mapped onto the other, and for every query you do with the delegated unicast subdomain, that maps to a corresponding multicast query for almost everything. But there are some exceptions. And I added some text discussing that. So there is not a full bidirectional mapping. For example, the document recommends that if there are linked local addresses in the multicast DNS address records, then those linked local addresses are suppressed for queries coming from outside the local link, because the linked local addresses wouldn't be useful. So that's an example of where the .local multicast namespace and the exported namespace don't match. There are names in the local one that aren't exported. And in the other direction, there are little differences, and I have one on the slide here, that there are certain metadata records, like the SRV records. So how you find the push notification server for a given subdomain is you look up the DNS push._TCP SRV record. That record does not actually exist in the .local multicast DNS namespace. So that was something that the document didn't discuss, and it's a potential area of confusion. So we wanted to clarify that. And in particular, the one that is described here, after Ted had finished his implementation and we're using it and it all seems to be working fine and we're very happy, it was a bit slow. And to start with, we didn't look at that because we were just happy it was working, and Ted was working remotely from Vermont, and we're doing service discovery from 3,000 miles away, and it's kind of exciting that it's working. But once we started looking more closely, we figured out what the delay was. And the answer is, when I'm using a shipping version of this code, now this, in 2 years' time, we won't care, but right now, I've got existing code which is looking for the old UDP-based LLQ protocol, which Ted hasn't implemented because that's obsolete and it's going away. And because all those queries map into the corresponding .local query, it would try and retry before it gave up, and that would add a 6-second delay before any operation succeeded, before it fell back to the old simple queries and polling. So once we made that realization, it seemed wise to point out in the document that there are some of these names that are special and don't simply translate back and forth in the obvious way. So that update has also been submitted. I will run RFC diff to make a comparison to help seeing the differences and post that to the list. I think what we want here is consensus from the group about whether these are merely helpful editorial changes or whether they change anything about how the protocol works. And if we decide they are changing something substantive, then we need to make the decision about what level of last call we need to do to review these. But as with the last document, we felt that letting this go ahead in its current state was not the best service to the community, and benefiting from this implementation experience we had and putting that in the document was serving people coming after us to be implementing this. So that's the update on those two documents.
Thank you, Stuart. Any questions for Stuart? All right.
Okay, I have 15 minutes, so you guys are going to have to ask a lot of questions because I'm not going to talk for that long. I'm Ted Lemon. I've been working with Stuart, as he mentioned, on doing an implementation of all of this cool stuff that we've written documents for. So we've implemented all of these specifications at this point. Stateful operations, hybrid proxy, discovery proxy, DNS push, service registration protocol, and discovery relay. So stateful operations is actually being used both for DNS push and for discovery relay. So we have two different things using the same DNS stateful operation code. Indeed, actually three things if you count the client and server of discovery relay as separate, and actually four things if you count the discovery proxy and the client as separate things. So that stuff is all done with the exception that I haven't actually done the server-side keep alive code because I was kind of under the gun to get something out the door, and that was the lowest priority. But that shouldn't be too hard. The client-side keep alive code is done, so I will be probably hacking on that and testing it in the next couple of weeks. Meanwhile, if anybody wants to actually see the code, that URL, which I'm sure you can probably, I doubt you can read very easily on the screen, but I'm sure you can find in the meeting minutes or in the meeting materials. That will get you to the actual implementation. It's inside of the hackathon repository that we were using. Discovery proxy. So that's what Stuart was just talking about. Really, we've got a standalone discovery proxy. It acts as a authoritative server for the zones that it's proxying, and conveniently, it also will do DNS lookups for other things. So you can use it as a DNS resolver, which is handy for the HomeNet application. That's part of why I did it that way. It relies on MDNS Responder to do MDNS resolution, and it implements DNS push so that you can get a timely notification of changes. And again, the code is at that URL. Currently, there are a couple things missing. The code is able to identify what link a request, or it's able to decide what link to send a request to, but I haven't actually implemented the link naming stuff that's in the discovery proxy document. So that's still to do, and I'd really like to get it packaged up for OpenWRT because I think that's one of the really nice use cases for this code that I think a lot of people could try out very easily. But that's relatively little work, so mostly done. All the protocol work is done. DNS push, so we have, as I said, we have an implementation of the discovery proxy, and then also MDNS Responder, which is a DNS, it's a Bonjour, how would you describe it, Stuart? It's the thing that does Bonjour discovery for you and also does Bonjour advertising for you. If you use Bonjour in Mac OS, it's actually going through MDNS Responder, but it's an open source project. And what we used in the hackathon was actually a branch of the Apple code with some additional stuff, all of this new stuff that we're talking about here in it. So that is actually doing DNS push now. So you can actually build it and install it on Mac OS if you turn off some protections, and it works nicely. Source code also available, and I need to add the keep alive support. So I need to implement the server side and I need to test the client side. Service registration protocol. So this is where we have a specially constructed DNS update that is checked for consistency, self-consistency, and then if there isn't a conflict in the zone file for the update, then it's just added. And the update includes a key which is used to sign it. So the update is validated against the key that was used to sign it, and then if another update comes in for the same name that uses a different key, that isn't accepted. So you get first come first served naming as a result of that. I've implemented a very simple SRP client that generates an update, signs it, sends it. I used ECDSA because that seems the target for the simple SRP client is an IoT device that's low power, doesn't want to do a lot of work. ECDSA is a good choice for that. It's also very compact, so so the update is actually quite small. I thought I put the size of the update in there, but it's like 415 bytes for a complete service advertisement using SRP. It's one packet to the server and one response back, and the response would just be a DNS header that says yes, thank you. And then I've also implemented an SRP proxy. That's essentially an SRP server. It receives SRP updates, checks them for consistency, checks the signature. I haven't quite gotten it to the point where it's actually doing a DNS update to a DNS server, but that's the next step. So that's all working. I think I mentioned the validation, that the ECDSA validation works with bind 9, so I assume that bind 9 is doing it correctly. When I first did the code, I read the SIG0 document, implemented it sort of naively, and had successful validation between the proxy and the simple client, and then I tried to do it against bind 9, and bind 9 rejected it out of hand, and it took me a day or two to figure out why bind 9 didn't like it. It's the way that SIG0 works is quite obscure. Yeah, I wouldn't put it that way. But that's done. So the remaining work is we need to have an SRP client that actually does the full SRP protocol and not the simplified SRP protocol, just to make sure that all that stuff works. But I don't see any reason why it wouldn't. It's very straightforward. It'd be nice if the SRP proxy was actually updating bind 9. And it would be kind of nice to hack SRP support into bind 9. So these are things that are on the agenda, but none of these are things that I think are sufficiently. I think we've exercised the protocol well enough that I feel like the specification is mature. So it'd be nice to do some more work on it, but I don't think we have to before we publish. The code for all of this is in that link. It's all open source, Apache 2. You're welcome to check it out. Discovery Relay. So Discovery Relay, the idea is essentially a Discovery Relay is like a DHCP relay. A little bit more complicated than a DHCP relay, but has the same essential function, which is a really stupid thing that doesn't have any features you can add to it. Its only goal is to essentially act as like an extra network link for a centralized discovery proxy. So you have a centralized discovery proxy. It connects to the Discovery Relay using the Discovery Relay protocol, and effectively it has access to the link that the Discovery Relay is on. That means you can add all of your features to the Discovery proxy. You don't have to add any features to the Discovery Relay. You don't have to keep the Discovery Relay particularly up to date, and it'll still work. So we have an implementation for that in MDNS Responder, both the client and the server, and they work great. I've used them to do discovery over 3,000 miles of internet. Remaining work, Discovery Relay requires TLS support, and it doesn't use PKI. It uses pre-shared keys. Not PSK in the standard sense, but just like a self-signed key that you would configure as opposed to using PKI to validate. I haven't actually tried that bit, but I'm pretty sure that the specification is correct. I updated the specification after doing all the TLS work for DNS push, and so I think it's correct at this point. So I'm reasonably happy with it and feel like the document is ready. So lessons learned. I mean, you heard Stuart talking about stuff that came up. He didn't mention every single thing that came up. This was a very fruitful exercise. We found lots of little minor nits in the various documents. We updated them, and I think at this point we have reason to think that these drafts are mature. So action items, it'd be really nice if anybody's interested in implementing, like doing a real full implementation of some part of this work. It would be nice to get another person to do that, and please talk to me if you want to try to do some interop testing. I would love to do that. I'd love to help you get up to date, but don't ask me any questions about the protocol because I want you to read the specs. I think we're ready for working group last call on the relay document. It passed last call once before, but I just wanted to hold off until I'd done the TLS work, and I feel like at this point the TLS stuff is good enough. SRP I think is ready for last call, and Stuart already talked about Dnssd push. So that's my status. And I'm done. Any questions? All right.
That is really great stuff. Yay. So you asked for last call. We're thinking of going ahead and taking that to the list. That meets your needs. Anybody complain? Good. Yes, Tom, you're up. Well, let's bring you up, though.
Oh, yes, my bad. I didn't.
Let me make a comment about the last call first. Because everyone's so busy this week, I don't think it'd be a good idea to start the last calls after this meeting, but maybe next Monday we could start them, and then we'd have time to.
Yeah. What I generally do is start it during the week, but make it go for 2 weeks from the end of the IETF, precisely because that way people can review it this week if they want to, but no one is time pressured to do so.
Okay, this draft came out in February. It's the first time I've talked about it, and the idea, we haven't actually got to the recharter work, but one of the things that I hope becomes a recharter item is how do we transition to a unicast-only discovery model to better serve the Wi-Fi clients that are a bigger proportion of our user base. And if you're not aware of the problems there, it's mostly having to do with waking up clients that are on battery and having to use additional power requirements to receive multicasts that they end up not needing because they don't have anyone needing that service or don't provide that service or things like that. So the idea is if we can transition to unicast, we better utilization of the access points and better battery performance on the clients. So the goal of the update proxy is to transition entirely from MDNS to a unicast only system. This diagram will be referring back to it doesn't have anything update proxy specific in it. It's just kind of so we can reference things to talk about how they work from a unicast perspective and to kind of refresh the clients that are both on this net here or out external will make queries for services on these subnets, and we need a way to map those into the unicast DNS namespace. And the discovery proxy is one way to do it, and it does it dynamically. And this update proxy is a alternate way to do it that does it a priori to build the entire list. One of the problems with the deployment of wide area bonjour was that all of the clients couldn't get a shared key that they could send updates to, a authoritative servers. It didn't scale well, and you didn't want to distribute those keys. And so by having a few trusted boxes in your infrastructure that have those keys act as a proxy, you can then scale the updates better and do the service registrations all over unicast. Okay, it uses the same subnet model that the discovery proxy uses that you should already be familiar with. One of the nice features is because you now have update access, you can create the subdomains for each IP subnet on demand. You can create the delegation. You can create the SOA records. You can then create the IP address enumeration records so that the clients can find the subdomain. It's all can be automatic, and you end up with an auto configuration system that only relies on knowing the single shared secret in the update proxy to be able to do an update, and then everything there can build on automatically. And then the clients, it's transparent to them. They as long as the domain, the top level domain is in their search domain, the update proxy can insert the browse pointer records at the domain level so that it can add the subdomains as needed, and then to the clients, this all becomes transparent and automatic. So it's a it's quite neat because of how easily the whole thing builds automatically. You configure the one shared key, and as the update proxy becomes aware of its IP subnets, and they can come and go or whatever, and they can be reconfigured, it can add them, it can configure them, it can make them browsable, and then start sending updates for the services that it discovers. And the other nice thing is each client that's on these individual networks can transition independently. So initially, it's going to proxy the MDNS stuff, but as the clients learn about an update proxy, they search for an update proxy, they find it, they can unicast their announcements to the update proxy and transition independently from multicast MDNS to unicast only.
Tom, you said the clients are sending their announcements. Do you mean the services?
Ted, please state your
Tell
name.
them.
Yeah, sorry, the services.
Yeah.
The client and some clients, a box acts as a client and a service announcer potentially. So. Okay, so when an update proxy starts up, it has to determine the subdomain. It has to make sure it can send updates and they're accepted. And after that, it can go ahead and create all the infrastructure to make that subnet mappable. It can start out by passively listening to MDNS announcements. It can send a query for the services, services Dnssd, UDP local to try and find services that are on that network. And as it discovers services, and when you first announce a service, you'll send it twice so that people who may have sent a query recently but weren't online at the time, those updates will get out. And so you can use those announcements. And then once you learn about these things, you can send unicast QU, which are query unicast queries to it to refresh it. You listen for the goodbye announcements where the TTL is 0 and you can delete it, and then you can remove it, send the update to remove it from the unicast server. And along with the records that you send in the update, you can either include the lease lifetime option, or you could actually add a timeout record at the same time, which and Tim's going to talk about timeout records later, but it's another way to transfer the life of that lease for the update announcement. Let's see. Yep. So as a refresher of the way that the subdomain name can be determined, both clients and the update proxy can search for the subnet and what would be like the default registration domain, or the registration domain, and there's a list of them, the browse domain, the default browse domain, and try to determine what the subdomain is if there's one already allocated for the subnet. If not, it can create one on demand and register it so that all the clients can find it, and other update proxies on the same subnet can know that it's already assigned. And you can have multiple update proxies on the same network, and they can work independently, but they can work redundantly. And you can either just have them both send updates and one of them will fail because it already exists, or you could have them try and coordinate by seeing if something there before they try to update. I'm not sure if that's worth the extra effort, but so one method of maybe generating the subdomain on demand is to use some algorithmic way to do it, so that you create this unique identifier, and everybody, you don't have to worry about guessing, well, what should I call this? Does it matter that it's, the engineering department versus the marketing department, or building 1, floor 1, and building 2, floor 2? It doesn't really matter. You don't necessarily care about any of that. So just these names are not going to be ones that appear in UIs typically. You're looking for the actual service, the SRV instance name, not these names. So I'm not sure that it really matters what they look like. So I talked before about how clients can individually transition to unicast-only service discovery by looking for the update proxy, and they can do a query, SRV query for a reserved service name based on the subnet address enumeration method to find the update proxy for that subnet, which it should register that record, and then that's all done via unicast, and the client doesn't have to use any multicast at all. So this is the idea behind this is a way to transition to unicast only, but comparing it to the discovery proxy, which is another way to map from multicast to unicast, is helpful in understanding how it works. So I put this summary slide together. As far as state goes, the discovery proxy tries not to keep state for things that no one is interested in. So it minimizes state as much as possible, whereas the update proxy tries to learn about everything that's available. Because it's putting all of the services in the unicast authoritative server, and when clients query it, they query the unicast server and get a response immediately back. So there's no go search for the service. Okay, it's instant. It's either in the data the authoritative server or it's not. So we have to get everything in there. There's advantages and disadvantages to this. The response time is much quicker, or I shouldn't say much quicker. It's potentially quicker if it's not already in the cache. If they have to go search for it with the discovery proxy, then you end up with maybe a slight delay, probably not, that's not a fatal problem. It's just the response time would be quicker in the case where everything's already in the unicast server. The discovery proxy will increase the amount of multicast on the networks based on the number of subnets that are browsable times the number of queries and responses that it receives. So without the discovery proxy, those multicasts wouldn't be there, but you're adding external clients over unicast, so that generates those queries. The update proxy will only add one multicast query, and that's for all services. And as the unicast, as the clients transition to unicast, that becomes not necessary in the long term. But the update proxy will make unicast queries to refresh all the services to make sure they're still out there. And that will increase unicast traffic as opposed to multicast traffic. Now, in the end, if you look at a switch, when you do a query, if you do a multicast query on a switch, you've got all these ports with all these clients on it, or all these, hosts on it, and a single multicast gets replicated on every port. And a unicast, and if you send multiple unicasts, it gets replicated on all those same ports on the subnet. So as far as the number of packets going out, I'm not sure there's really a difference. The replication is done in the hardware of the switch under multicast typically, so it might be less load on the switch, but it's the same number of packets going out on the back end. With the discovery proxy, because it doesn't know all of the services that are out there, you can't do DNSSEC NSEC records, because that tells you what the next record is, and you don't know what the next record is, because there can be holes between your knowledge. But because the update proxy knows all of the services, or attempts to know all of the services, it knows what the next records are. So you can use DNSSEC as you get updates and send them up to the authoritative server. It can rebuild the zone with the correct NSEC records, and everything can be signed with DNSSEC, and you can have DNSSEC signed service discovery. As far as the complexity goes, there's, I think we need feedback from implementers to validate, that the discovery proxy has to implement a full authoritative server. If it does the MDNS relay, so that it can have like a single discovery proxy that everything gets collected in, that's additional code to write. Whereas the complexity of the update proxy means it's mostly just passive MDNS listening and doing some unicast queries, plus sending updates to an authoritative server. So to me, it seems less complex to do the update proxy, but I think that has to be implementation dependent. Do you want to? Okay, you want to respond
thanks,
to that?
Tom.
Yeah.
I stood up because I think this is a good chart and this is useful. I had a couple of things of feedback.
Yep.
Maybe update this as this presentation is given in other places.
Yep.
Where you say order n squared, I think it would be good to clarify what n is, whether that's number of clients, number of servers, number of links.
Yeah, it's number of subnets times the number of query plus responses. Because when you do a unicast query, it gets sent out to every subnet, right? The client will query that and then get a list of subdomains back, and it'll send out queries to each one of those, which will do an MDNS query on each one of those and get so many responses back. So it's number of subdomains times the number of responses, basically, plus one.
Right. Those are not necessarily the same number, right? They're not both n. It might be
No, it's
n
order
times m.
It's order n squared because it's, a times b. It's the order. It's not n squared. It's the order n squared.
Okay, so that's why I'm saying it's a little bit unclear what the scope of this is, whether you're looking at the amount of traffic on a particular link, or collectively the amount of traffic in the whole world, or what it is that we're measuring.
Collectively for the unicast query, the single unicast query that comes in.
I think a single unicast query goes to a single discovery proxy, which is connected to one link, right?
No, a single unicast query for a search domain gets broken up into all the browsable subdomains. The client will do that query, get back the list of subdomains, and then do a bunch of queries for each of those.
We can maybe talk about it
Yeah.
in more
Yeah.
detail
Yeah.
offline. I think think in the case
It's
of update proxy, saying there is only ever one subdomain, and for discovery proxy there could be n subdomains, is not an apples to apples comparison.
No, I'm not saying that. So yeah, we can talk about
Right.
that. There's one per in the update proxy. There's one per subdomain.
And as you implement this and test this,
Yeah.
we can get real operational data. I think you may be being a little bit optimistic with the order one, which is another way of saying there is no change in the multicast traffic at all. It's one times what it used to be, which is no change at all. I think when you do the underscore services meta query, what you're actually going to be doing is you do a multicast query to discover all the service types represented on the network.
Yes.
For each of those service types, you then do another multicast query to say, find me every instance of every type on the network.
Yeah,
And then for
yeah.
each of those instances, you do another multicast query saying,
you can do a unicast query at that point once you have the instance name.
once you have the instance name, you still don't know who to send the unicast to until you've resolved that.
Address. Yeah. Okay.
The
I'm
the
SRV
device
target.
giving right.
Yeah.
Right.
Yeah, okay.
The source of the multicast packet may often be the same device as the thing that's offering that service, but not always.
Yeah.
So, in general, you need to do another query.
Yeah,
So,
you're right.
my intuition here is that the amount of traffic is probably going to be comparable, and probably it would be possible to show that in any case the discovery proxy is strictly less traffic on multicast traffic, because the update proxy has to exhaustively discover everything that's on the network that anybody might potentially ask for in the future. Whereas the discovery proxy, because it's on demand, is by definition only discovering the subset of all possible services that clients are actually interested in. So I think it has to be strictly less, because it's discovering fewer things. And then you talk about DNSSEC. I think there you want NSEC 3, because the idea of NSEC 3 is to prevent zone walking, which was an attack discovered with classic DNSSEC that some people were concerned about, where from looking at the NSEC records, you could then enumerate all the contents of a zone, which had privacy implications. NSEC 3 added some cryptographic hashing to make that zone walking infeasible. In the case here, and I believe the draft talks about this, so if it doesn't, we should fix it. Discovery proxy allows online DNSSEC signing, not offline, which is a little subtlety. It's not saying you can't use DNSSEC, but you can. The device has to know the key. What you can't do is the classic keep a PC in a locked room with a floppy disk and sign the zone offline and then walk the floppy disk out to the server. If you really, really want to have very strict isolation that device can't be compromised. You can't do that when you're building this dynamically, so the device needs to own the key, and that is an additional vulnerability. But that's not quite the same thing as saying you can't do DNSSEC. It's just that you're only doing online signing.
Yeah,
with
no, I
DNSSEC.
didn't make the claim you couldn't do DNSSEC. I said you couldn't do NSEC records.
Well, you can do NSEC records, and I think it talks about that. If somebody does a query for a name that doesn't exist, you generate an NSEC record that says this name doesn't exist.
Okay.
And if they do a different query for a different name that doesn't exist, you send them an NSEC for that. What you don't have is NSEC records that straddle a whole range of names that says none of these exist. But that capability was actually a failing of NSEC because it enables zone walking. So the inability to do range NSEC records is arguably, that's not a deficiency because that was not considered a desirable property of NSEC records.
Okay. No, that's a good point. Thank you. So I'll update that. Okay, so there's some issues that are kind of outstanding in the spec that I need to work on. I need to walk through the implementation and match up to the spec and make sure that everything gets created correctly and it's listed in the spec of what to create to make it the auto configuration all work transparently to a client. In the case where an update proxy fails and it leaves subdomain information behind and another update proxy takes over, just want to document to make sure that that transition happens, cleanly. I had some questions, and Stuart and I can talk later, or we can, if now's appropriate, that's fine. But if you want to register a service in multiple domains, then, and the R registration domain query comes back with a list of multiple domains, is that okay to just register that service in all those domains? Or like for when doing address enumeration of the subnet?
I will let the chairs guide us in terms of how much time we have left for discussion. We are here to have a working group meeting, so to some extent, having this discussion publicly instead of off in a corridor somewhere, I think is appropriate as long as the time allows for that.
Don't worry, we will cut you off mercilessly if it becomes necessary.
It saved us a lot of time.
So the domain enumeration records were originally created when we optimistically thought that device vendors would implement DNS update for themselves. And for a variety of reasons, that turned out not to happen. It makes me sad that even today you can buy a network printer that advertises its service using Dnssd, and the service is vendor printer dash hexadecimal vomit, because they think if you make every name unique out of the box, that solves the problem, right? Because you look at the list of printers available in AirPrint, and you see 12 different printers differentiated only by the hexadecimal string on the end. And as long as you memorize hexadecimal strings, then you know which one you're using. Getting people to even put in a meaningful name for the printer by going to the web UI and typing in a name turned out to be, in practice, apparently too much of a hurdle. So if you're not willing to give the thing a name, configuring it with a key is certainly not going to happen. So that was overly optimistic. It never happened. And the point I'm getting to here is don't be overly constrained by what we were hoping would happen 10, 15 years ago. If it's appropriate to define new mechanisms or new conventions here, that is totally on the table. Those old records were there with an intention of giving guidance, so that when you connect your new device to the network and go to its web UI, it says, I see on this network, the administrators are recommending the following 4 domains: sales, marketing, engineering, or first floor, second floor, third floor, and you pick the one that's appropriate for your device. Since that never really materialized, we're not beholden to that. We can define new mechanisms if that's appropriate for what you want to do.
Okay, great. All right, and then the last point was that it's possible to do subscriptions through the push notifications to the authoritative server if that's ever implemented in an authoritative server. There is we just had a discussion at the hackathon about the reconfirm message, and it's not possible at this point to get a reconfirm back to, there's nowhere to send a reconfirm if you received one at the authoritative server. But what the reconfirm triggers in the discovery proxy, I think the client could do manually when it would have wanted to do that. When it recognizes that thing's not responding, I think it can just make the queries that it needs to do without using the reconfirm in the subscription. So that's something that we can pursue as well. So those are the outstanding issues, and I'll update the draft as I work through these. As far as implementation, there's one I'm working on. It's partially working, but it's not actually sending the update out at the moment because of a concurrency problem I was having in the code as I learned Rust. But I think I've worked through the issue in my head now, and it's a matter of re-architecting the code now. It does listen to the MDNS announcements that are out there and builds a cache and then sends updates for new entries into the cache and times out the cache entries. Listens as it gets the goodbye packets. It doesn't send the updates yet as well for those to delete the entry. I'd like to add TSIG support to it and do it over TLS as well. Right now it's all over UDP. Do the subdomain discovery and auto configuration stuff. Add dynamic interface support, so as addresses are added on an interface, it'll automatically recognize those and start providing update service for that subnet. And then work with maybe some either some switch vendors or some router vendors that I happen to know from previous lifetimes. So that's all I have.
We're going to ask to keep the questions a little short because I'm apparently bad at math and we are a little bit behind schedule.
All right, well then I'll make this very short. Thanks for doing this work, Tom. I look forward to seeing this progressing. We can help you with testing over the internet remotely and in person at the next hackathon. One suggestion I made to you directly, but I want to share it with everybody in the room. In your current draft, you have a little appendix that's comparing this with Ted's discovery relay idea. And what I would actually suggest is, instead of viewing that as an either-or kind of approach, the way I think of the discovery relay is it's analogous to a BootP relay, which is used by DHCP. And the idea is that routers have these simple BootP relays that have not changed in 20 years. And in the data center, there's room for innovation. New DHCP servers come out with new capabilities, and that innovation can happen without you having to upgrade every router in the enterprise. And that decoupling enables innovation. So I would definitely think about having your proxy, as well as working with directly attached physical interfaces, view the discovery relay as like a USB Ethernet interface with a really, really long USB cable on it that runs over TCP. But it is a way for you to have an interface on a network that you're not physically connected to with hardware, but it's as if you're connected. And then all the stuff you would have done locally, you can do remotely. And if we're successful in getting those relays deployed in routers, then they provide this capability. They're like your little minions out on the network, which the discovery proxy can use, your code can use, other future things. It creates this ability to innovate because you don't have to keep changing the routers when a new idea comes out.
Yeah, that's a great point.
Ted Lemon. So I don't want to make you answer this question right now because I think it would be a little bit difficult to answer it while you're just standing there in front of us going like, ah. But I don't understand. Like, so we have the hybrid proxy, the discovery proxy. We have the service registration protocol, which provides a migration path to DNS update, so that we're using unicast only if we can get all the clients to implement it. And so it feels like this is actually solving the exact same problem. And I get that the characteristics are different, but it would be helpful to have kind of a clear sales pitch for why this is a good thing to do and why it's different. Because at this point, I actually don't know. I mean, when I first started looking at this problem, I think Stuart and I remember we were meeting in Argentina at the IETF there and talking about this, and I actually proposed something really similar to this because, like you, I wanted to have a complete zone file with everything in it. And we had a pretty long conversation about that, and I came away from the conversation concluding that actually that wasn't a really good idea. Doesn't mean that I was right or that Stuart was right, but it would be good to actually capture that discussion and be able to express clearly why it is that this is different and good as opposed to the same thing and not really different.
Yeah, the short answer is that I implemented the discovery proxy and found it to be, I think, more complex than I would have liked. And adding on the MDNS relay and discovery relay and all those components, you guys were able to bootstrap from MDNS responder. And that got you to where you are today rather much quicker, right? And certainly that's an option for people. Some people may not be able to do that. Some people are going to implement from scratch. And I find this solution to be simpler, less code. I don't know that it's better. I thought that it was worth writing it down and implementing it to see. And I'd love to have more people work with me on it because it's lonely. But
so in the
that's it.
Oh, perfect. Thanks. Ted, could we ask you to repeat this question on the list? Because we don't have time right now, but I would love to see maybe a comparison of the two solutions. And you had one about the discovery proxy and the kind of N-square style complexity, and getting to the bottom of this on the list would be really helpful.
It might be worth actually just doing a document. It doesn't have to get published, but just doing a document that explains, that picks apart the problem, because I think having a discussion on the mailing list is, we're probably not going to get to the point very easily.
All right.
So
thanks for volunteering.
Oh, yeah.
No, but more seriously, can the two of you collaborate on that? That would be incredibly helpful for the working group. Thanks. Let the minutes show that Ted made a thumbs up. All right. And Tom, you can go sit down, and Tom, you can come back up.
I'll try to be quicker on this one. Okay. So we've talked about different privacy options, and I thought I'd throw another one into the mix here. The idea is that we already know how to search for services in a subdomain. If we can make that subdomain private, then we just do what we normally do. And that's, we make normal queries and get normal responses. So the idea is, let's make it easy to create new subdomains that are both encrypted and authenticated. And if that's not too much complexity, we have a way to do private service discovery and among your devices or among a group that you define. And so the idea is that all the queries and responses are encrypted. They can be over TLS, is what the current document says. The previous document said, well, we could do these queries in the clear, but the actual records were encrypted, and that got too complex. So this one, that was the 00 version. The 01 version says, let's just use TLS. You create a private subdomain by having a prior relationship with some entity. You might have it might be your email provider, it might be your own domain, it might be somebody that you buy services from. And in my example, if I have email pusateri@bangjay.com, the bangjay.com domain can create a route for private subdomains under pvt.bangjay.com. And then I can, owning Pusateri, that email address, then they will have some policy to allow me to create that subdomain based on maybe some credentials I already have, like my email credentials, or it could be first come, first served, like TED's service registration protocol does, and only if there's a problem or a conflict, would they. But when you first create it, there's nothing in there, so you're not exposing anything. And the way you create one is you use update to create a key record at the apex, and that key record is the public key. And then from then on, all operations that you do in that private subdomain has to be signed with the private key associated with that public key. So you do a query, you would put the query, you would sign the query with a 6-0 signature using that your private key. It would go up to the authoritative server, which would then verify using the public key you put in there and make sure that you really have the private key. You then distribute those private keys to all of your devices, and all your devices add that subdomain name as in your search domain, and you're able to search and update records in the private domain. Let's see, if you want to update the key record, you can do that as long as you have the old key record. If you want to use client certificate, I think it'd be possible as well to put a TLSA record with the public key, and then the server could verify you're the right client using the TLSA record that's at the root of the apex.
Mohit, so I'm trying to understand this. You get a URL, so or in this private space, and there you put a public key.
Yes.
And then you put the private key corresponding to this public key in all your devices.
Yes. So you sign all of
How do you do that? Like, where do I generate the key pair, and then how do I export the private key, share it across devices, and put the public key at this URL? Wow, this will take me a while to digest this.
Yeah, it's really, I'm not trying to dictate the policy and how that happens, but there are a variety of ways that could happen that they're not currently enumerated in the draft, but that's something that we could do as possible ways. I think that current providers do that for you today. Now, you may not trust a provider to create the public-private key pair and give it to you and not keep it, but that happens today, and a lot of people have rolled out services doing that. And I think iMessage is an example where that's done today, where the keys are distributed for you by that provider.
Tom, Christian Whittemore. Tom, I'm not sure I understand, but do you suggest that all the devices that are authorized to interact with a subdomain have a copy of the public key, of the private key?
Yes. Yeah. So today you do that with SSH. You might have. Well, you don't have to. No, that's not
no, you don't do that with SSH.
Yeah, you have different keys. I'm sorry.
You have different key for every device.
Yeah.
And if you don't have different key for every device, I mean, there is.
Yeah.
There is an issue of resilience of what happens. I mean,
Yeah. I mean, there certainly, well, we can talk about it more on the list.
I have one question.
Yes.
My name is Ashutosh. The intent here, as I understand, you can correct me if I'm wrong, is to keep these domains private.
Yes.
But things like certificate transparency log, which is very popular, so there you can get the subdomains from there, right? So if a certificate is issued and all the private subdomains are, one could go and get the private subdomains from there. If assuming that certificate transparency log is also the owner of the website is also populating their certificates in the certificate transparency log. So one could also retrieve it from there. So
okay, yeah. Well, I mean, people do it today with PGP. There are probably other ways that they synchronize private keys.
Alrighty, can you wrap it up?
Yes.
Thank you.
Okay. I think we talked about most of this. We're getting half a page of it.
Oh, that's odd.
Okay. Okay, so I can put some of these questions out on the list, but this is kind of some of the things I wanted to get feedback on. The under PVT nomenclature, that I'm not sure if that breaks the attribute leaf rules that were recently published to use it in this way, and it wasn't clear when I read the document, so I need to find out more about that. This is the issue that Christian brought up, synchronizing the private key. And, you know, if you have a group, you might want to have some people, a lot of people be able to read it, but only a few people be able to update it. So we could have like a write key as opposed to a read key as well at the apex. And then Tim and Willem both brought up the point of maybe you want to separate encryption and authentication, so that if you wanted to provide, you know, public records, you could do that. So that's it. Any more questions?
Thanks, Tom. We'll ask for, if there are any more questions to them, bring them to the list, please.
And maybe if we send that discount for this.
Sure. Yeah. All right, Tim, you're up.
All right. So since Tom was talking quite a bit, presenting our timeout draft, which is just for those of you who haven't read the draft, quick overview what we are trying to do with it. So it's introducing a new timeout resource record, which is essentially to hold information of how long other resource records can be considered valid, and it gives them a lifetime. So after this lifetime, the authoritative server is supposed to remove them. The idea to have this as a resource record is simply to have this information be stored right in the zone where you have all the other information about the records. And this way you can transfer it to your secondary servers. And even if you have like a multi-vendor setup, it's not a problem. You just have this information in one place and can transfer it regarding any vendor-specific things you might have done in other cases. Also, you could do an implementation which survives restarts or crashes of your server software. But if you don't, then this resource record will save the information when the
when the record is supposed to expire in the zone, and yeah, you will also have it if something fails. So what could fail, for example, if you have services which are registering via, for example, the SRP or the update proxy or anything else, the cleanup might not happen. And even though you might have a update lease option, so you know how long this record is supposed to be valid, you know the EDNS0 option doesn't provide a mechanism to transport this lifetime and to save the state between different instances of your name servers. So that's kind of the idea. I've been, during the hackathon this weekend, working on an implementation of a little daemon which provides this functionality by just looking through the zone, grabbing the resource records, saving a timer for later to remove them when the expiry time has come. And once it's reached, it just sends out an update to the authoritative server, and the records are removed. So simple as that. To keep it short, just a few next steps which Tom and I were thinking about, or which would be interesting to us. First, we'd like to have feedback. If you have an authoritative server, would you implement this? Or if not, why not? I mean, strictly maybe that's better question for DNSOP, but yeah, doesn't hurt to ask as many people as possible. Another thing which we were discussing during the weekend, we have like a represented record type in each instance of a timeout record, and it would be, or what we were discussing is if it would be okay to let the represented record type be any, and then the instance is valid for all types under the owner name. Yeah, maybe if you have some ideas about this, or if you think that's a good idea, because if you have like an A and an quad A record, now you would have to have two timered instances, and this way you can just have only one of them.
Ted Lemon, you might consider having there be in any record that is superseded by any more specific record.
All
so
right.
in other words,
Messy.
well, yeah, the whole thing's messy.
That's doubly messy. I don't want to put it.
Hi, Peter Lexus Power DNS. I had a quick look at the draft just before I went in. We're not against implementing this. However, we don't have plans to do this anytime soon. And there was one little thing I didn't see in the draft. It does not mention that the timeout record should or should not be queryable.
Okay, we had it not explicitly not being queryable before.
Way, so that might be.
Okay, yeah, we had the discussion in an earlier version where we specifically said we don't want to have this queryable, and it turns out that brings more problems than anything else. So it doesn't say anything because we thought it's okay to have it queryable.
Yeah, so I had a small discussion with Withold earlier today, and he mentioned thinking about making a non-meta meta-R type, like a range, like we have the meta types now, that are explicitly not queryable. So will only be represented within an XFR. So it might be interesting for you to talk to him about this.
Okay.
So the initial discussion of this, Joe Abley said that he wanted it to act like any other resource record. And when we had it not queryable, he's like, we don't want special rules. So that's why it's now queryable. And it also allows you to do update to add and remove it and know it's there. So there is advantages to having it queryable.
All right, but thanks.
Stuart Cheshire. A couple of comments on the draft. At the start, in the introduction, you give some motivation that compared to using the EDNS0 option, the benefit of having this be a real DNS record are that it can be saved on disk and it can be transferred to secondary servers. I think you can make those justifications a bit tighter, because we do have ways of saving data on disk that's not DNS records, because like my digital camera does that every time I take a picture. We do have this technology. I think you've got a good argument that if you want to save it out as a textual zone file in a way that is portable between different DNS vendors, then having this other metadata stored on disk in a proprietary format is not portable. So I think that would be a crisper argument for that it gives you portability. It's not that that's the only way to save data on disk, but it saves it in a portable way. The other thing that was a bit anomalous, and I'm not sure how you'll clean it up, but you start off by saying the great benefit of this is that it's transferred to secondary name servers. And then later in the document, you say that secondary name servers must not do anything with this data. If they're never going to do anything with it, then the benefit of transferring it to them is less clear. So I think that language could be tightened up a bit.
All right. So the idea is that only the primary server removes the records. So if you have a failure of the primary, then the secondary takes over the role as a primary, and then it has the information of removing the records when the expiry time has come.
All right. Question, yeah, I'm going to cut off the line to save time. Question as chair. Is this specific to Dnssd, or does this sound like maybe something that should be presented in DNSOP?
No, if you have a look at the name, it's kind of intended to be in DNSOP, also as a discussion, but because, well, for example, the service registration would be one primary use case of this, we thought we would let the working group know.
Absolutely, and thank you for presenting this. It's very common that, like with the RC that Sir was talking about that just got published, DNS stateful operations, for us to have documents in DNSOP that are discussed here and that our documents rely on.
Yeah, and just as an information, we had plenty of discussion on the DNSOP mailing list already because we posted the draft over there.
Perfect. Thank you. That's just what I wanted to check. All right. Thank you. And Christian, you're up.
And we've successfully made sure that you have less time than was originally allocated on the agenda. So just letting you know.
Okay, I'll just speak very quickly.
Well, the original allotted time was 40 minutes, so you still have plenty of time.
Oh, no, I don't need 40 minutes. I don't think I do. Do I have a clicker? Yes.
Yes.
So yeah, if you have followed the various episodes of the evolution of private DNS discovery, we have been through multiple ideas, and we managed to converge on a set of requirements that narrow the problem. We have a requirement draft that shows the scenarios that we want to serve, which are effectively people that know each other or devices that know each other arriving on the same network and performing a multicast discovery locally without giving away their identity or their presence or things like that. And we don't want to give away the identity of either the client or the server. And among the discussion we had also clarification that we don't necessarily want to maintain binary compatibility with Dnssd. So I look at that and says, if that's the case, I can have binary compatibility with something else, which is TLS. And so, where's the click? Yes. So, I'll set a first set of assumptions there about what what we assume in this presentation. When I speak of TLS, I speak of TLS 1.3. And the reason for speaking of TLS 1.3 is that TLS 1.3 is the first version that has any hope of providing server privacy. Because in the version prior to that, the response from the server carried a clear text version of the server certificate, and so much for server privacy. Now, that is fixed in TLS 1.3, so that's a good thing. We can say, hey, we can have a TLS response, and it doesn't disclose the identity of the server to people on the link. It does, however, disclose it to whoever set up the connection. The next thing that we have in this toolbox, which is actually a work in progress, is encrypted SNI. Now, the TLS initial request carries a service name indication, which is effectively the domain name of the server, to simplify. Now, of course, and that's carried in clear text. So, of course, if your initial query carries a name of the server in clear text, again, the hope of privacy are very limited. But we have recent development on how to encrypt that thing. And it's encrypted by effectively having a public key of the server accessible to clients so they can use it to encrypt it. And that way, only the intended server can decrypt the SNI. And that's meant in particular for big server that serve a lot of different domains. So you can connect to the server, but you don't know to which particular domain you connected. And the third assumption in the design is that we are going to use UDP-based transports. Now, you're of course familiar with TLS over TCP, but there are variations that do not use TCP. And the two interesting variations there are DTLS, which is basically straight TLS over UDP, and Quick, which also use a TLS exchange during its initial handshake to set up the encryption key, and then is encrypted and carried over UDP. So these are the assumptions in the design. So then, basic ID. The basic idea is that if we have TLS protocols that are carried over UDP, then I can send the first packet in the exchange over multicast. And that first packet over the exchange carried the encrypted SNI of the target server. So if I do that, it's received by every server, or well, in fact, everybody who cares on the local network, but they try to decrypt it, and only one of them will succeed, the guy that has the corresponding private key. And so that gives you a way to do a discovery request followed by trial discussion, and if that matches, well, you have a 101 TLS-based connection. And what attracted me to the design is that it has the property of doing minimal innovation in terms of encryption and processes, etc. You get TLS. You get TLS, and you don't have to innovate, discuss which key you use or whatever. It's all specified. You benefit from a lot of investment in a TLS working group. You benefit from a lot of investment in the ESNI design because there are pitfalls there to verify that the thing works. So that's the general idea. Now, there's one difference with the ESNI design, however. The classic, it's a work in progress, so calling it classic is kind of weird. But the ESNI design relies on DNS. And basically what you do is that when you go to the DNS, a property of the server tells you which encryption key you shall use for the ESNI. It gives you the public key that you shall use. Now, it turns out that if you broadcast that public key, then anybody can use it, and anybody can do a request on the local network, says, hey, Christian, are you here? And I will be able to decrypt it because it's my key, and they will know I'm here. So, well, we don't want that. So instead of putting this ESNI key in a public space for everybody to read, we say, no, we are going to use that as a control point so that this public key is only delivered to the clients that are authorized to discover me. And so inasmuch as I keep that public key secret, and here we start having a problem of vocabulary, but inasmuch as I keep that public key only disclosed to authorized client, I have, in fact, a private discovery system. Now, you want, in the document, we had discussion on that on the email list. We want to not call that a public key because if we call it a public key, it's a recipe for trouble. So we'll call it the discovery key. So the server, each service has a discovery key, which is only available to authorized clients. So that gives you a property that only authorized client can issue a discovery request. And then when they get the response, they know that with certainty that the response comes from the authorized server because the SNI design has a proof in it in the response to prove that the server is who they claim they are. And that design is actually fairly resilient because the fallback mode is that, yes, there is an error mode that you have given that discovery key to all your buddies, and one of them is a traitor, or one of them is careless and leaks the key. Well, that design is fairly resilient because in that case, you go back to ESNI. That means that, yes, it will be possible for someone to discover me because, hey, my key has leaked. But at the same time, it won't be possible to tell which clients are trying to discover me. So we have this fallback mode that if the key leaks, the server can become discoverable, but the client identity is not discovered. So that's a nice property. Yes?
Mohit, so kind of like the idea, at least from what I have heard so far. My question is, TLS by its design is a little bit asymmetric. You have a client and a server. And in Dnssd, maybe devices are more like peers that discover each other. So it's like if my printer is discovering my light bulb, I don't know why it would. Who would be the client and who would be the server, and how would they decide on the roles to use?
In the scenario that we are looking at, I mean, we have looked at Stuart, for example, as a key scenario in which the diabetes app on his cell phone is discovering the insulin pump in your belly. These things are really peers. And the high-level response is that any one of them can act as either server or client. It's a matter in application design.
But the server's public discovery key, as you call it, must be somehow out of band communicated to the client.
That is true.
So,
but if you have the insulin pump property, you can very easily say that basically during the synchronization, the pump gets the application's key, and the application gets the pump's key, so that either can discover the other.
Okay.
Chris Wood, I was just going to comment, isn't that the same scenario with the existing proposals that we've been discussing so far? Yeah, that's not a new problem, I don't think.
Yeah. Okay. So let's go to where we have small issues. First, I mean, it's not clear that all applications that need private discovery will run over Quick. And they will eventually, because Quick is going to take over everything. But, I mean, it takes some time. So in that case, what we can do is have a two-phase scenario in which in the application that has to be discovered, you also have a small implementation of a discovery protocol that runs over this TLS ESNI discovery and provide something like a DNS over DTLS or DNS over QUIC, so that what you do is that you discover that DNS service co-located with your target application. And once you have discovered that, you ask them a bunch of DNS query to understand exactly how to actually get to the application, and then you get there. So from a deployment point of view, then we have to write that application once, and you can ship that together with the other application and get to discovery. Okay. Remaining gap, we had the discussion on the email list. And the target of the design is really the private, more or less peer-to-peer application to device scenario in which a device is paired with pretty few applications, pretty few clients. I mean, that's if you take the insulin pump, for example, you are not going to peer the insulin pump application with very many pumps, with just a few. So in those peer-to-peer-ish scenario, we don't have a really big scaling issue because, well, the number set is very small. But it is true that if you want to discover something, the client that comes on the network is going to send a bunch of multicast requests for every server that they want to connect to, every private server. And it is true that there may well be deployment cases in which that number is large. So that's the downside of that proposal. The other downside, which is related, is that if the client arrives first and only the client can do the discovery, then the client will have to repeat the attempt, and that's a downside. I think that is not a practical downside because I believe that if you look at the scenarios we have in the requirements, those scenarios tend to be very much peer-to-peer. And so it's effectively whoever arrives last tries to discover the other one and finds them when the last guy arrives. But, I mean, yes, the combination of two is a scaling issue. And I looked at how would I fix that if I had to. And if I had to, I would invent some kind of a server announce message that the server broadcasts when it's saying, hey, I'm here. And it will be signed with the discovery key of the server so that everybody start to try decrypting that message and say, oh, my body has arrived, now I can contact it.
So this Chris Wood, the discovery key for announcements would be used for signing, and for being discovered would be used for decryption of the ESNI.
Yeah, there are some loose ends there, that's clear. Yes.
Okay. We'll probably have to figure out, like, not use.
No, you could use LGAMAL and things like that. It's not impossible.
No, I'm not saying it's impossible. I'm worried about the use of a key for two different purposes in two different contexts.
Okay, yeah, we could.
But that's like a solvable problem, I think.
No, of course, yes.
Yeah. Also, it seems it's a bit unfortunate in that we will be using something as heavyweight as TLS for one side of the protocol, but not TLS for the announcements and the lighter weight I am here messages. I don't really have a proposal for resolving that. It's just
no, and it's true that basically if you send a TLS message, the TLS message will include your handshake proposal, and you really want to have separate handshake proposal for separate people or separate peers.
Yes, I agree with that. Yeah.
So I mean, you tend to get this scaling issue anyhow because of the security requirements.
I guess my comment, and perhaps
my practical thing is that we're probably okay with that.
Yes.
That's
yeah. Okay. I did have a possible proposal for a variant of ESNI. that might make it a bit easier to deploy. So currently in the draft, you distribute out of band the discovery key for all of the clients, and you use that to encrypt the ESNI key, and everything works. But potentially rotating that discovery key is problematic. I don't know how you would actually do that in practice. Perhaps you have another issue. Right. I was going to propose potentially instead of distributing the discovery key, you distribute a certificate, basically a trust anchor that the server will possess, or have a certificate chain that will route or chain up to something that is distributed out of band, and then you can rely on the fallback mechanism that David Benjamin proposed for ESNI to distribute the new discovery key in band and sort of rotate it a lot more quickly without having to build in any additional infrastructure.
Yes,
anything.
and that will be a solution for this particular slide, which was my next slide. They say that there is one problem. There is one problem with anything that relies on a basically those discovery rely on publishing a public key. And if you publish a public key, you have a failure mode, which is what happens if for some reason your private key leaks. And you want to have some resiliency there. And it turns out you have the same problem with ESNI in general, and with anything which is based on public key, is that if you leak the private key, bad stuff happens. In our case, what happens is that if the public key is compromised, not only can someone impersonate you, but they can also go back to all the logs that have been captured by hackers at us in the last 20 years and look at every places you've been. And so that's not good, okay? And the solution has to be frequent key rotations. And that's something we have to work on in practice.
Yeah, agreed. I am kind of suggesting make it as frequent as possible, and that you could, in theory, just always have the server give the client a fresh discovery key, enforce a retry, an ESNI retry upon every single connection. So
it doesn't help you with privacy.
Why not? The key is sent in the encrypted extension.
Oh, okay. So you basically the server remembers the old key. If the client tries to use the old key, you send them a rekey immediately. That's kind of
the idea. And I apologize for bringing this up at the mic because it's not really well formed or anything. But so the client just assumes it doesn't know what the key is of the server whatsoever. It just happens to know how to authenticate a certificate that the server will present because it's been given.
Well, no, that's not good either.
Why not?
Because if the client doesn't send something specific to the server in the request, then every server responds, and the client receives the certificate of all the servers that are present, and that's not a good property.
Okay, yeah, there's a trade-off there. So I would agree that that's not ideal, but something to consider, I guess.
No, I mean, look, but clearly we want to work on these details and work on it. Clearly, I could see, for example, incorporating the key rotation in the handshake process, the same way that you get a new session token each time you do a new session, right?
Yeah,
that's doable.
Yeah, cool.
Sorry. Ashutosh Singh. My question is, so the ESNI recommended mechanism to exchange the key is DNS over HTTPS in the ESNI document.
That's correct.
So is this an alternate? Is that?
Yes.
Okay, cool.
Well, Chris, to clarify that, I don't think you would use this to get the ESNI key for normal web traffic, right?
This is not designed. This is designed
for
a very specific application. It's not designed for, your server that sits behind the Akamai CDN or something. It's not what you're looking at there. Okay, and yeah, I'm in fewer than 40 minutes.
Perfect. So, go ahead.
Mohit, quick question. What's your thought on session TLS session resumption, and does the server ever issue a ticket to the client and then you use that later on for discovery? I haven't thought this because I'm, now listening to you, but
that will.
I mean, if the server issues a new session ticket after the handshake, what happens
yes,
later?
I look at that, and that's the reason why I kept the ESNI design, because the ESNI design is completely parallel to the session resumption. So basically, you do ESNI all the time, no matter what, because you need to understand the ESNI to understand whether the ticket is valid, to understand whether that's for you. Okay, but if you do that, then you can have either a full handshake or a resumption. Now, there are privacy issues, so if you are the client using that, you have to be damn sure that you use the session ticket only once.
So stepping in as chair, I've been noticing a pattern that anytime we meet together on this topic, there is a lot of cryptanalysis at the mic, and you actually do make progress. So I'm thinking maybe but then on the mailing list, 3 months go by and not that much happens. Which, we're all busy. We all have jobs. Like, no one is actually currently being, 100% on this. Would it help if maybe we set up like a side meeting later this week with like a whiteboard, and we can kind of let you bang it out? Would that be helpful?
Yes, provided we have time.
Yes, that would be a good idea. Yeah,
Okay.
it would be provided there's time.
It would be good, yes.
I will see what I can do to help make that happen.
Okay.
Show of hands in the room. Who would like to very actively contribute to this? Because this is probably going to be hard to find times. Okay, people who. Yep. All right.
Are you able to record those names? Okay.
No.
I'll just sing Stuart and Chris. And
Christian. Yeah. Cool. Thanks. Yeah. Well, yeah. Yeah, well, we will absolutely announce it on the list. It's just it's going to be hard to find times that everyone can get to. So we'll do our best. Thanks.
Sorry to interject. Maybe still one clarifying question on these keys are generated, like these are ephemeral keys for both the, like for if there is a server that's like has a key pair, and then one of them is the discovery key, is it like ephemeral, or is it like, do you envision this is printed on the device?
The discovery key can be generated basically any way you generate your public private key pair.
Right, but
you have to then install it on the server and install the public key part as a discovery key on the authorized clients.
Okay, and this is, so I'm not Dnssd guy to know it well enough, but this will run like in a local subdomain network, and you won't be discovering across the internet.
No.
Okay.
No.
Thanks.
No. That's not meant for discovering across the internet.
All right. Thank you, Christian.
Thank you.
real quick. Charter. More specifically, possible recharter. I think this will work. So Tom did an excellent job at loading up our Dnssd GitHub with, well, the current charter. That was pretty easy. And also there, and you see it's GitHub Dnssd-WG if you're curious. Also, there are 7 open issues that have received 0 comments. So I'm thinking, are people willing, is there anybody willing to work on this on GitHub? Is there anybody willing to work on this? Okay. Okay, I will send out an email link to the GitHub site, and I'll go ahead and list these 7 issues that Tom has started there. And if people would actively, specifically, I think, as you can see from the issues that Tom started us with, there's milestones, which of course chairs can actually update without necessarily rechartering. But the refocus of the privacy work, I think, was a key one. And the privacy and data integrity. So, alrighty, we will send out an email to the list.
All right. Thanks. Or does anyone have any comments or questions? Can you plug in a second? Does anyone else have any comments or questions about the recharting and what we're doing there?
I think some of this is going to require discussion because we have to decide as a group what new things we want to do. And a couple of those things are new and a couple of those things are existing. And so I didn't feel comfortable, writing up a new charter to say we should now do these things, because that's really for all of us to decide if we want to do them or not. But yet I can't get any discussion to occur on are there new things we want to do? So like the finding things near me versus finding things, I forget the other one was. Yeah.
Sorry, we completely lost video. So, all right.
Yeah. Yeah. So,
that is a good point. Thanks, Tom. I think, we'll want to discuss this on the list. I think when Barbara sends the list of issues, hopefully we can spark a conversation there and make sure, because you're absolutely right. The charter is just a reflection of what the room wants to be doing. So it's important to agree on what we're doing, not before we agree on the text, because otherwise it's kind of moot. Thank you. So this wraps up our Dnssd session in Prague. Was kind of great to see some of our documents are moving forward. We're hopefully going to be done and have published the discovery proxy in before Montreal, so we can all have champagne there. It'll be great. And a lot of the other documents are moving forward nicely, which is really cool. And as always, many ups and downs with privacy. We're making good progress. It's good. Okay, so thanks everyone for coming, and we will be meeting again in Montreal. But in the meantime, do read the list, because there's a bunch of interesting stuff coming there. Yes, Tom.
Sorry, one more thing. Ted, could you tell us what you're going to do in this afternoon at the...
Oh, yes. You mentioned the hack demo?
Right, yeah. Yeah, so just FYI, I'm going to be sitting up at the hack demo happy hour, and maybe Stuart will be there too. I don't know. Yeah, Stuart will be there too. And basically, just if anybody wants to sit around and play with Dnssd in one way or another, Stuart or I can help you to understand the APIs that are available. We can help you to build the source if you want to build the source, and we can help you to do anything else. We don't have a particular agenda unless Stuart is about to state one.
No, I'm reinforcing what you said. At the Hot RFC session on Sunday night, Ted took that opportunity to talk about what we've been doing. One of the things that we have discovered talking to people at the hackathon is, even though the service discovery technology is fairly mature now, a lot of people at the IETF don't know what it does, or in some cases have never even heard of it.
Or have wrong ideas about what it is.
Or have very wrong ideas about it. So Ted had this idea, which I thought was great, that let's use the hack demo happy hour time slot as a chance to talk to people and answer questions. So Ted pitched this at the Hot RFCs, told people we'd be there. The audience, so anybody in this room who wants to talk is welcome to come. We were hoping to reach the people not in this room who know nothing about this and have an opportunity for some face-to-face chats.
All right. Thanks, both of you. I think this is helpful in getting our work spread out. All right, thanks. That's a wrap.
Yeah, let's do this thing, huh?
Yeah. I mean, it's glad that it. Well, I was going to display it, just that slide because I didn't type it up. That's kind of silly. Oh, I can. Post the agenda. Oh, sorry, yes.
Okay.
Yeah.